Hello everyone. A few days back we had a session online with Professor Ashok Saxena. And those of you who do not know Professor Saxena, he has been a textbook figure and he has done enormous amount of research on creep crack growth and creep fatigue crack growth, and he also developed a fascinating parameter which solved a lot of problems with the conventional crack characterizing parameter in the creep and creep fatigue crack growth. And he has been working in the field of mechanical engineering, especially in the mechanics of materials, for a very long period of time. He had a very large career in this field, and he has been head of the department and then dean of University of Arkansas, dean of engineering, and then provost of the university. And we had the opportunity to ask a few questions, and the questions were related to the how the students are in the Department of Metallurgy and Materials Engineering at IIT Roper and also nationwide. And because Professor Saxena has an experience of working with students, being a university professor and dean for a very long period of time. Also, he has written textbooks for the students. So it was a great pleasure to have the experience and compare the students of USA and India, and how the materials research in materials and education in the field of metallurgy and materials has developed there and here. And so I'm sharing this interview with him, and I hope you would like it.
As a professor of material science and engineering. And then in 6 years later, I became the department head, which a position I kept for about 10 years. And then I got recruited to go to University of Arkansas as the dean of engineering. I did that for a number of years. I ended up in University of Arkansas as the provost of the university. Provost is the position to which all the deans report. So I had 10 deans at the registrar's office and the entire academic side reporting to me. And there also I took a brief 2-year assignment to come back to India at Galgodia's University for 2 years. And I was the Vice-Chancellor there, and it was strictly a 2-year assignment. So I completed my 2 years and went back and rejoined my position in Arkansas. And since retiring, uh, I have been very active with a small company in Virginia, and I serve as the president of that company. It's a company that makes vessels for storing hydrogen at very high pressures. And it's an R&D company at the moment, but we are actually preparing to launch our first product. In fact, when I go back in January, that would be something I would be doing full time. So here I am. I've done a number of things. To think about, I often say to the students that you have to prepare yourself for a 50-year career. And I've been now, since my graduation, it's been 55 years and I'm still active. So eh, I've worn a lot of hats, done a lot of things, had wonderful journey, wonderful career. I would not trade it for anything, and very happy in my life, professional life as well as my personal life.
It's a long journey, sir, and there are lots of contributions. Even I think half of the world have got your contributions, even the entire world. Thank you
Oh,
so much for your contribution, sir. So we'll continue from our yesterday's discussion. So there were lots of students yesterday also, and they are going to join soon, and they
mm.
have lots of questions from you. So I think I can start with the very first question from you regarding the industry related projects. So if you could guide us about the how to pursue the fundamental research in scenario when we are seeking more funding from industry and industry related projects. So what should be our approach in that case?
Yeah, I think that's a very relevant question and a good question. Uh, I think ultimately engineering research is about uh, being of benefit to society. You know, a long time ago, I heard somebody say the difference between a physicist and an engineer. A physicist is somebody who solves an approximate problem and gets an exact solution for it, whereas an engineer is one who gets an approximate solution to an exact problem. So problems are the things that drive us, and we should not shy away from that. Uh, Ultimately, uh, the importance of research is measured by the impact it makes. And impact, of course, if the problem is worth solving, is going to be more. So a lot of times in formulation of research, or in research, the quality is defined by a choice of the problem that you work on. So, and that comes from practical applications and industry. I very often also say that I really learned how to do research at Westinghouse Research Labs, because there you had to justify what you're doing on the basis of its applications. Now, it could be long-term applications, but the applications are important. Now, having said that, uh, people will fund you to do research that is applied, and that is what they care about. But as an academic researcher, it makes sense for us to dive deeply into it. And a lot of times I found that if I wanted to write scientific papers, if I wanted to do scientific work, I had to take those projects that were applied in nature
Exactly.
and focus on the fundamental aspects on my own. And that is what helped me get a full professor's job at Georgia Tech, 10, 11 years after I finished my PhD. Uh, if it wasn't that attitude, I don't think I would have been able to make the transition from industry to a university. Okay, so both are important. For academics, it is important to do basic fundamental research, but at the same time, hopefully, you derive the problems you work on the basis of the impact that the solutions are going to make.
Yeah, exactly, sir. Because what we have seen, most of the time industries are just only result oriented. They want results only, and they are not interested in the fundamental research. So that's what the problem occurs most of the time. So, do you remember any sort of struggle during your times when did you face any trouble in doing such kind of things, pursuing fundamental research along with the industry project? And what did you learn with those struggles in your time?
Again, very relevant question. There are struggles, but they're mostly internal. You have to basically satisfy yourself with the quality of the job that you do in response to a research project. And very often, when I first went to work for National Steel Corporation in Weirton, West Virginia, my vice president, who was also a graduate from University of Cincinnati, so he took me under his wings, and he said that, here we do only applied research. You've done a lot of basic research as part of your PhD. You will learn how to switch to applied research. And then I did some things on my own on sheet metal forming at that time, and created a very nice fundamental model for for the drawing and ironing process of containers. So I showed him some of those things, and he was just so glad and so he was happy that I was able to do that. In fact, for the next 1 year, wherever he traveled, he took me on his airplane with him so that he could have me describe to the customers what we were doing. And there he would say, we have the ability to solve practical problems, but we can also address some fundamental issues. And Dr. Saxena is one of those who's doing that. So a lot of times people in industry will say that they don't care about fundamental research. But if you solve their problem, and on top of that, you show them that you've gone into something very deeply and modeled it and done some fundamental research, you will find that they will be very happy. So uh, I think, you asked me about struggle. I gave you an example of exactly the opposite.
Yes, exactly, sir.
Yeah.
Yeah, good, sir. I think many of the students are interested to ask you a few questions. So I would encourage anyone of the audience, please, you can throw your questions on, sir. Yes, please, Arzu. Please go ahead.
Hello, sir. I had a question on behalf of all the UG students pursuing metallurgy and materials.
Yes.
That's a, yeah. So even before exploring our research capacities and other opportunities in our particular branch, we tend to get inclined towards non-core or SD fields just because it's more highly paying, like it's alluring you. So even before exploring our side of core, we already make our minds to pursue another branch. So how to tackle this mentality?
Well, I don't know that you should tackle the mentality. I think on the other hand, there has to be acceptance. We follow career paths. I did mechanical engineering, went into materials. I went into materials because some things attracted me there. So as we talked about, we can look forward to a very long career, and you have to try different things. So I wouldn't say that you necessarily want to tackle those things, but I do believe that the statistics, at least in the U.S., is that only 25% of engineering graduates, 5 years after graduation, are actually doing engineering. 75% are doing everything else. And the medical schools, for example, love engineering graduates. The business schools love engineering graduates. And also, in various walks, the investment bankers love engineering graduates. And that is because the training that we receive as problem solvers and analytical thinking, this is what they're after. So it's not something that we should try to stop. But on the other hand, it is important for us to keep the discipline going and contributing, because there are problems in the realm of metallurgical engineering that only we can solve. So we have to appeal to those 20-25% that are not going to get swayed away. And you have to make sure that you don't turn them off to go elsewhere. So be aware of the fact that the people are going to move into other things. And in fact, I proudly say that engineers can do anything. And that is not necessarily a negative, it's a positive. But at the same time, yes, engineering has its own needs. And those needs are not going to be fulfilled if 100% of the people follow that path. And that is not, so you need to make sure that you don't turn off anybody that is genuinely interested in the field. So did I answer your question, or?
Right, of course, sir, my question is answered. We should keep exploring, like even though we belong to a certain branch, we should keep our minds open.
Yeah, I had 6 or 7 career changes in my 54 years. And part of it was because I felt like I was trained to be able to do that. And you go into a new field, even this whole field of creep and fatigue. I remember my boss coming into my office back in 1977 and saying that, I know that you know a lot about fatigue, but what do you know about creep? And my answer was, Nothing, but I'm willing to learn. And he gave me a couple of projects that established me for the next 40 years in the field. So interests change, uh, people evolve. That is a natural progression. And whenever you try to go against the forces of nature, you produce conflicts.
Ye- Yes, sir. Please, sir. So Dr. Abhishek have some question, I think.
So if other students have, they can ask before. Then I'll ask. Well, so then I will ask my questions. I have a few questions. So, sir, one question is that these days AI has come, and that has gone into research and manuscript preparation and coding preparation, and books have been replaced by video lectures.
Mhm.
So, do you think it is detrimental for the research, or there is a common way where both can live together
Yeah.
by a better use of that?
Yeah, I am an optimist, and I'm going to look at the positive side of all this. Uh, it used to be the learning. Let's look at learning, for example. Learning used to happen in classrooms where a teacher was in front of 40 or 50 students writing on the board, explaining things while 80% of the class was asleep, right? So they were, and you can say that people have attention span that is different. People have different ways of learning. Some people learn by doing things with their own hands. Some people are visual learners, and some people learn very well by listening to lectures. Now we have all these different modes that we can bring to bear to enhance learning. So, for example, when I was at Georgia Tech, I used to my lectures were being videotaped and were being sent to GE, where there were a bunch of engineers who were part of that Edison program while earning a master's degree in engineering as part of their first 3 years of training. And but I used to keep those video lectures in the library at Georgia Tech also. So one day I decided to go and see the library log as to who is looking at those lectures. And to my surprise, I found a lot of students in my own class were borrowing those lectures and replaying them and learning from those lectures. So, and I did see that the performance of the students was good. So I think you have to look at it in that sense. Now, there is also issue about AI, for example. And this is a very active discussion at this time. Uh, uh, if I'm writing a proposal today, I can write a few things and I can assign ChatGPT to write some paragraphs about that. And very often I see what comes back is perfect. You take another look at it and say, yes, this is good stuff. So in one way, it has enhanced my productivity by not having to spend a lot of time trying to write something down and then improving the English and presentation and all those things. So that part is good. But if you completely rely on something like this and you don't learn as much, then that could be the negative side. University of Arkansas, I noticed, just came out with a policy on the use of AI in classroom discussions. So what they're asking all the instructors to do, and I teach online, so I have to basically put online a paragraph saying what my AI policy is. whether or not it is acceptable for students to use ChatGPT in responding to homework and problems. So I think it is still being discussed, but I know at least in the universities in US, there are some very serious discussions going on, which are at the fringes of whether ChatGPT, whether we should let people use ChatGPT because there are some positive aspects to it, versus uh, discourage people from using it because it can tamper with their learning.
Yeah, thank you. And about AI, I agree with you, but with the video lectures, so what I experience is that many of the students are watching video lectures, but they're not reading the books at all. So do you think watching video lectures can give you all the information, because the PhD students are in this stage where they are learning their craft to
Right.
do whatever problem they're solving. So even if I watch your lecture maybe on creep crack growth, will I get all the info or most of the info? For example, the derivations, first principle derivations and all. Something will be missing there.
Yeah, well, I in fact do have very elaborate videos on the creep crack growth and creep fatigue crack growth and use of J integral and fracture that follows my book on advanced fracture and structural integrity. So I have a set of videos about, I think about 25 videos that go through those topics. The primary benefit, those videos are primarily written for the benefit of people that are already working. So they need to do some continuing education. And in that respect, I think those videos are good because there it's not as important for them to learn how to derive things. It is important for them to know what is there. And hopefully from the video lectures, they get enough information and get some motivation to go to the book and read it if they really need to know in depth. With the graduate students and undergraduate students, I think people were using Cliff Notes and keys and things like that. Even at the time I was going through my 10th grade education, a lot of people. So obviously they have to understand how they learn best and how to combine all these resources that are available to enhance learning. That part is good, but if the objective is just to pass the exam, then let them do it. Ultimately, they are the losers.
So I have another question, and that is, so we have seen a good technological boom in the field of computer science, so coding or mobile phone or networking and things like that. So is it the reason that computer became so cheap that it could be given to anyone and they could do anything with it, that resulted in this technological development? And if that is true, then we cannot provide SEM and UTMs to the students, right? So, so you think there is some limitation to material science to have that degree of.
No, I think material science has to embrace that. And the way to embrace it is, for example, if you want to use the SEM or if you want to use the TEM at Georgia Tech, you can find somebody to collaborate with over there. You can send them samples and they can arrange for a technician to put those samples in the SEM or TEM, and you can manipulate that sitting in your chair. So, for example, in the field of medicine, there is tertiary care that is available at very few places. But through through the media or through technology, you can have a very highly specialized doctor look at a patient who might be sitting in a village somewhere. So again, as I said before, I'm an optimist. I look at positive side of things, and there are a lot of positive aspects to it. And materials people have to understand that this first of all they have to demonstrate the value of what SEM and TEM does in solving engineering problems. That is an important part. And then you have to make that equipment accessible, and computerization is a means by which you can do that. So it's not all negative. That is all I'm talking about. And certainly the negatives are things that you have to understand and try to deal with. But don't throw out the baby with the bathwater.
Okay, thank you. So Avinash, you can.
Okay, sir. Okay, so I think Avanish Kumar Mishra have some questions from you, sir. Please, Avanish, go ahead.
Yeah. Good evening, sir. In a creep crack growth. So
Okay, you have to repeat your
my
question. You froze
question
for a
is.
minute. You froze for a minute, so please repeat
Yeah.
it.
Hello.
Yeah.
Yeah, I am Monish. I'm working in the field of creep and creep crack growth of stainless steel. My question is, what are the future scope for me in the field of research and education in foreign?
Yeah, in where? I'm sorry, in foreign? What did you say at the end?
Yeah, he said in foreign. Yes.
Okay.
In US or.
Yeah, I think there is US is always looking for good people. But I think what is happening is that they are the support is sort of drying out, and a lot of times if you hire a postdoc, for example, from abroad, you may face some difficulty in finding the financial support for it. Back in 1970s, that support was a lot easier to find. It is becoming more difficult, but at the same time, it is still there. Typically, a lot of times you say that you want to go as a postdoc, and you have to find the places where there are some very active researchers. And those active researchers are the ones who have the research grant that can support somebody. So that said, I would also say that you should remain flexible. You may not be able to get in a place where you get to do exactly what you've been doing for your PhD. In fact, that is not a very good situation anyway, because you've done your PhD, you're supposedly an expert on that. So it is probably better to go out and try something else and broaden your portfolio to set yourself up to someday go back into teaching and research on your own. If you graduate in creep crack growth and you want the project funded in creep crack growth, you're going to be competing with your advisor, right? And with a lot of disadvantage. So it is probably better to diversify a little bit and find something different to do. And often people do that during postdoc years, because it's very hard to duplicate exactly what you've done and find somebody who's interested in funding that. Occasionally it happens. There are a lot of people who run very large groups, and they're into all different types of fields. But their knowledge is limited, so they're looking for postdocs who fill certain niches in their research groups. So that also happens, and that's a good position to be in. I wouldn't be discouraging, but at the same time, look for different things. Don't just basically put all your eggs into the basket of going somewhere for postdoctoral studies.
Thank you, sir.
Okay, anyone else from the audience? Okay, so I have a questions once again. So if I ask you, what would you advise to young professors to pursue their research in the right direction? So what would be your advice to them?
Well, I think you know, teaching is what makes you popular with students. Research is what makes you popular everywhere else. You know, a lot of times your university is going to be judged. The quality of your university is going to be judged by the research productivity and the quality of research that it does. So if you want to have an international reputation, you have to pay a lot of attention to research. And in research, the number one thing is, what do you want to research in? And that is where the relevance of the research is important. It cannot be that somebody at some well-known school is doing research in a certain field that gives you justification to do research in the same area. There has to be somebody who cares about what you produce as research results. So, going back to that example of how I got into creep and fatigue, the Westinghouse had lost a couple of turbines. And that's a huge, huge situation because you have a big corporation at that time. In 1975, it was worth $6 billion. Translated into today's money, it would be 50 times more than that. And what had happened was their turbines blew up. And somebody brought the pieces back into the lab and saw traces of creep and traces of fatigue. And they said creep fatigue. And they said, well, it originated from a defect that was a manufacturing defect. So that defect actually grew for 15 years in service. And then it caused the ultimate failure. So they came to the Corporate Research and Development Group, where my boss, Ed Vessel, had a very good group of people that were working on this problem. And when he came to me, I realized that I don't know much about this problem, but if I do come up with a solution, people will care. So I think constantly looking for a good problem to work on. Somebody comes and defines that problem to you, how to adapt to it and then look at it in depth and look at all aspects of it. And also, people have limited attention span. So somebody brings you a problem and they say, I could have at that time told them that give me $10 million in 10 years and I will have the solution for you. They would have left my office right away and never returned. Right? So I think you have to understand, as an engineer, as a researcher, you're part of a larger ecosystem, and you have to play your role accordingly.
Yes. Okay, so thank you so much. Sir, what do you think? What would be the top areas of research which would change the world in the near upcoming times, specifically in the field of materials and metallurgy?
Yeah, I think anything related to environment would definitely be very important. People are talking about making solar energy cheaper. So I think that stems from materials research. So any kind of advancements you can make with solar energy, would be useful. Urban infrastructure, reliability of bridges, reliability of roads. That there are basic materials problems with those. They're not just metals problems; they're materials problems. I consider concrete to be a material, an engineering material. So I think if you look at it in the broad sense, there are lots of issues with respect to that. Access to clean water, where membranes and things like that are important. Then you have things like carbon sequestration. If India is going to continue to use fossil fuels, I think it is a good idea to basically work in the area of carbon sequestration. Obviously you may not be able to apply your creep crack growth theory to it, uh, but uh, but you can apply your education to come up with some solutions. And then lastly, I would say tools for scientific discovery. Somebody said SEM and TEMs and OJ and all those things. These are all tools that can be used for research in very different fields and for solving all kinds of problems. So there is still a lot to do in the field. And for example, hydrogen embrittlement, it's been something that has been studied for 75 years. But in the context of hydrogen storage at high pressures, it has taken a new meaning. The work that I do for the Department of Energy now is looking at how long a pressure vessel is going to last if it is subjected to 1,000 bars of hydrogen pressure that is cycled. So I think materials for the sake of materials is not going to be important, not that, but materials as applied to solving societal problems is the way to attach yourself.
Okay, sir. Thank you so much. And I would encourage audience if there is any questions from your side. Yes, sir. Hari Prasad Gopalan is there. So he's going to ask his question.
Okay.
Thank you so much, Professor Saxena. I was a bit curious, especially in the context I was here for the introduction when you described about your career. I'm very curious to know if you have seen some kind of a cyclical nature of what is fashionable in research. Do you see trends that come back? For example, one context, I think Avnish had asked, he works on creep growth. I had worked on creep, but these are not, at least in my limited understanding, they're not very fashionable these days, if you want to talk about it. Do you think it's a temporal phenomenon? Yeah.
If you talk about creep and creep crack growth in the context of basically improving the thermal efficiency of power plants or turbines and things like that, it is still fashionable. Yeah, okay. But yes, things do go in cycles. When I first started my graduate school in 1970, research on composite materials was very fashionable, was very much in the vogue, and people were working on it. They took the field to a certain point, and then at that point wasn't really mature enough for somebody to use the technology somewhere. Okay, so the interest basically died off. The funding agencies came and put money in it for 10 years, and then they lost interest because it wasn't going anywhere. Then a set of new tools developed, analytical tools as well as experimental tools. And a lot of things that were not known about composite materials could be addressed again as new problems. And back in the mid-'80s, composites was again a huge subject. At that time, people were talking about making engine rotors out of ceramic materials because of their high temperature capability.
Right.
And because of that, obviously there were more advancements in that. And also people wanted to make lighter airplanes so they could carry more payload. And the problem with use of composites is that there were no good joining technologies. So people were afraid to fly on airplanes that were glued together. They liked the idea of a nice weld or nice joint that was strong. But then that is what led impetus to more research in adhesives and characterization of adhesives. So the fracture and crack growth of adhesively bonded materials was a huge issue for some time, and then it goes down. So I think that will happen. But people have limited attention span. They have limited resources. And new things are constantly coming up. So if you were an entrepreneur, or if you were a part of funding agency, you basically say that, well, okay, I put my money into this. I understand this problem. It has gone from A to B in terms of development. Maybe I should let it simmer for some time and put my money into something else. And that is why it is very important to continuously invent yourself or reinvent yourself. I have done that. My first administrative position at Georgia Tech was the director of the Composite Center.
Okay.
And it was a multidisciplinary center with 7 departments that were involved in that. And then, of course, I went into other things. Yep.
Sure. Thank you.
Thank you so much, sir. I think there are no other questions, sir.
Okay.
If there are no other questions, then I have some questions again.
Okay.
So yesterday you said that your role models were your parents. So has it changed, or they are still your role models?
Well, I know most of you speak Hindi, right?
Yes.
So I would say कि नजरिया बदलता है. Okay. I'm for always very indebted for the opportunity they provided me. And there are a couple of phrases that my father used to use that I find myself repeating a lot. Because he had certain wisdom. One of his phrases was, reward for good work is more work. And then he used to say things, so the context changes. And the context, instead of career advice, it changes from advice in life. So I have the same amount of respect for them, but I also have evolved away from them. So as your own ideas develop, you move a little further away from your original inspirations. But you can never forget the fact that your inspiration to be who you are today, you can never forget that.
Yeah, that's true. But are there new inspiration, new ideals?
Oh yeah. Sure. My PhD supervisor, he was a huge factor in my career. In fact, he was the one who first got me into fracture mechanics. I wasn't even thinking about it. I didn't even know about it. And I went to, by accident, I went into his office to talk about something, and the next thing coming out, I was working for him for my master's and PhD.
Can you tell his name? Who was your supervisor?
Yeah, Stephen Tolovich. Stephen D. Tolovich. A very well-known person in mechanical metallurgy. And just his, his drive, his intellect, here he was in my first semester there, he was teaching 3 courses. He was teaching a course on dislocations, he was teaching a course on composite materials, he was teaching a course on fracture mechanics. And also supervising 6 or 7 research students. And he was very young. He didn't have a PhD student at that time. I was his first PhD. And then later on, he impacted my life in a different way. I was in a TMS meeting in Los Angeles, where I was giving an invited lecture on creep and creep fatigue back in 1984. And
But that is also old. So has it changed? So do you have a current idea?
I'm coming to it. Okay. So after my lecture, he came to me and he said, let's go for lunch. And right there on the spot, he offered me a teaching position as a full professor at Georgia Tech. That is how I went there. Then he he was a department head. He moved from Cincinnati to Georgia Tech. He was a department head there. And then 6 years later, he left to go to Washington State University, and I took his job as a department head. Then a dean of engineering came along. He was a very important person. He was an industrial engineer, but had gotten exposed to materials. So he became my mentor, and he hired me as the department head at Georgia Tech. And I learned a lot from him, not about materials, but about how to motivate people in administration by being in administration. And then he left to become chancellor at University of Arkansas, and he got a gift from the Waltons, the owners of Walmart, and he got a $350 million gift. And then he called me and he said, "I want you to come and join me as the dean of engineering." His name was John White. And even to this day, we are very, very good friends. He is retired. I have retired. In fact, I go visit him in his home, and he comes and visits us in Atlanta. It's a lifelong relationship. And I really value his advice on things. Obviously, I cannot ask him about pre-crack growth, but everything else, he is my mentor. And similarly, now I am mentoring a lot of people. There is NSF, National Science Foundation, has a program where they pair young faculty with emeritus faculty for mentoring. So I just mentored somebody with an African American background, and he's a very, very hardworking person, but had never seen so many opportunities in his lifetime. So I helped him over a 2-year period, and he's now a full professor at Ohio State University. Then there is a woman of Indian origin, Suhasini Guru Raja. She was an assistant professor at Indian Institute of Science. She has now joined Auburn University, and I play that role for her. And every 2 weeks we get online and we spend an hour together just talking about all kinds of problems, all kinds of issues that face her. So it's not just important to get something from somebody, it's important to also
give it back also.
Yeah.
Mm. So do you watch Bollywood movies?
Yes.
Do you have any favorite?
Occasionally I do.
Do you have a favorite one?
I don't watch them with such intensity. I tend to watch those movies, and then some of them obviously make an impression on you, but I really don't have time to think and remember them. So I feel like it's a 2-3 hour period where you want to get away from everything else. You watch the movie, and after the movie is over, you're gone.
So which one is the latest you have seen? Any web series or movie?
That's a very interesting thing. I saw a movie just 2 days ago sitting in Varanasi, and I have no clue as to what the name was.
Okay.
So I don't, it's again, you remember things that you really care about. Yeah.
Okay.
And
I got the message. Okay. So thank you very much, sir, for giving your time to us. And I hope that we'll get your valuable time again for both of these kind of discussions, technical, non-technical.
Mhm.
So unless there is any question, I think we can end the session.
Okay.
Is there any question from the audience still remaining?
Maybe I have one question that came out of this discussion.
Sure.
I'm really curious to know your take on mentoring, for example, PhD students. How much of handholding is good handholding? So my own thesis experience was that my supervisor let me just go explore and find your own thing. And it took a long time, but it was one of the most rewarding experience in my life ever. But I'm wary that I'm not my supervisor, and therefore, what is the extent of hand-holding should one, especially when this who's just beginning their careers, for example, as an independent
Yeah,
researcher?
I think it varies from person to person. If you see, for example, some ability or innate ability in somebody for doing research, and you get the impression that they have read the literature, they know what they're doing, they're organized enough, they produce results, they write them up, then the last thing you should do is to interfere with them. Okay, you leave them alone. But then there are others who want to be held, who want their hands to be held at every stage. And if you have to hold them to the point where you essentially write their PhD thesis, then you can do that. But at the same time, you know that there is no point in holding on to them for a number of years because that is not going to change. So even if you have to give them a lot of help in writing their PhD